Good day, good morning, good afternoon, wherever you are. Welcome to my talk about autoscaling your Nomad jobs. First, let me introduce myself. Hello, I'm Bram Vogelaar. I went to university to become a molecular biologist, and according to my colleagues, I descended into the dark side in a couple of steps. First, become a bioinformatician, then in an academic world, the programmer guys, also the server guys, so started to do operations a lot, and since the last decade or so I've been in operations, and I'm currently employed as the CTO at a little hosting company called Hot Potatoes in the Netherlands. Today I would like to discuss moving it all to the cloud, because at some point in your life a CTO, CEO is going to come into your office and going to say, let's move it all to the cloud. It's going to be better, it's going to be faster, it's going to be cheaper. And let's work out, if it is, how you can actually build it in a scalable way, in that cheap way, and if you can build something that can actually survive the thundering herd. In order to look into the future, we need to look into the past first. So way back when you wanted to buy more compute power, you would actually have to get buy-in from probably investors. You would have to talk to suppliers. You would have to raise a purchase order. You would have to wait months for a very big box to show up to your loading dock that you would have to probably install into a purpose-built room or even a building. And if you wanted to have more, you would basically have to do the whole thing again. So capacity planning was a thing of years. You would have to plan ahead and have to have quite a bit of buy-in. In the 90s, early 90s, or a bit later, we got into a point where compute was commoditized. It was a lot cheaper. Things like the internet kicked off, websites kicked off, Google kicked off. They, instead of having to build bigger and bigger rooms or even buildings to house your compute, the industry worked out a way of basically horizontally scaling, so adding more nodes of the same size and just working out how to split your problem across multiple nodes. In the beginning that was fine. People knew task X ran on server X, task Y ran on server Y. But when the internet kicked off, things like vanity URLs, so google.com or mywebshop.com needed something in front of those nodes, and that's where we started calling load balancer. You would have one load balancer to have the vanity URL, your webshop.com, and then basically would serve out or rotate the work between the servers, and that's how you would scale out. This would allow us to set up a platform that would be able to accept far more traffic than before, but still problems like the thundering herd that we now had, whereas Black Friday, Christmas shopping, there would be a massive peak that we would have to basically buy hardware for, that would be running at zero capacity, at zero usage for most of the year, basically to be able to absorb the additional traffic for those very limited amount of time. And that's basically was because of the same problem we had before. Buying new servers was very, very expensive. It was a time consuming thing, so you could not basically say I would want to rent new capacity for a week, 2 weeks. No, you would have to buy them and install them behind your load balancer just in case it would happen. And then the actual cloud kicked off. So you could rent someone else's computer in a data center that was behind an API. Containers became a thing. So Docker rules the world. That needed a scheduler. So Kubernetes was invented. That made life increasingly difficult for people that didn't want to program in YAML. Then multi-cloud became a thing, so I'm not only running a cube in AWS, I'm running one in Azure or Google for good measure, and life became very difficult for people that wanted to run a stable, simple keep it simple, stupid platform. So the lovely people at HashiCorp created another container schedule. Well, actually, Nomad does far more than just container scheduling, but during most of this talk, I'm focusing on it being a container scheduler. It can do Java directly. It can do executes. It is plugin based, so the community has written plugins for most things that can house VMs, which are available on their website. But we're focusing on it being very good at doing containers. So as an example, let's deploy our blog. Actually, in case this is an overview of my blog, I run it somewhere in AWS because I have a reserved instance. And Nomad jobs look always like this. It's written in the HCL, the HashiCorp configuration language, DSL. They came up themselves. For people that are used to Puppet configuration management, this should look very familiar, but there's a couple of peculiarities. So you always need to have a job log, a job stanza with the name. It will have groups, one or more, and then a group can have one or more tasks. So in my case, I have a job that's called blog, will run in the AWS data center. There is a type service. There's a couple other types that we won't go into today, like batch, for instance. Then there's my group, called my blog's written in a tool called Hugo. I'm going to expose the HTTP port from the container, and my container runs in a basically fairly standard Nginx container that I pull from my private repository. And then I expose the HTTP port. Fairly simple. We run this basically Nomad run, then file name, or I can copy and paste it into UI, which is fairly nice. Now we have basically the same situation as before. We have one instance of something running on complicated infrastructure that was running on the VMs or the bare metals or the cloud instances that I had before. So that actually didn't yield us anything. So one is none. So if that one craps out or gets taken out, or the underlying hardware gets taken out, then we're in trouble. There's nothing. Nomad will try and restart the thing for you, but we're still in trouble. It will take a while for that to come back. So Nomad has the notion of counts. So I can tell it count is equals 2. So Nomad doesn't start just the 1, it will start the 2. And by using a console, which is HashiCorp's service discovery tool, and for instance a ingress controller named Traffic that can read console services, we can make sure that now we have 2 instances, and both instances will be used to route traffic to. Basically, traffic will be our load balancer from the original image, if you can remember. Now we have 2 instances. We can lose one, and the other one will take over. So we're a bit better prepared. But Nomad has a default scheduling algorithm that's called bin pack, so it will actually try and stuff as much of your tasks onto the same client node as possible. That's basically because it wants you to do this in the cheapest way possible. But since we're actually trying to extend our risk factors, well, not our risk factors, we want to cover all our bases, covering our risks. So when we do count is 2, it will actually originally it will start the 2 instances on the same client node, which is not something we want. So we want to make sure that we can survive that node dying or being taken out of the pool. So for that, the HCL, Nomad HCL has constraints. So we can say force, using constraints, we can force the 2 jobs onto 2 different clients. And in this case, the key to use is the operator's distinct host, and force it and you reinforce it by using the value is true. Constraints is a very nice concept, but if the constraint can't be met, Nomad will just not schedule it. It will throw a warning or an alert, but it won't actually schedule. So you think you might be covered, but you probably aren't, because the Nomad will patiently wait for this constraint to come true. Forcing it onto different nodes is probably fine, but you can have far more fine-grained stuff to use as a spread. And so if you want to make sure that it is spread when possible, then you don't use constraints, you use spreads. And in this case, I'm spreading across a meta tag called rack, and I want to have 50% deployed onto the rack called his, and I want to have 50% onto rack hers. So if any of those constraints isn't possible, it will actually accept that it isn't possible, and it will provision the task onto like the least preferred condition. But in that way, we can always make sure that there is at least two. The count is at least two. So even though it's not preferred, if we are worried about the thundering herd, so that we actually need 2 instances of 10 or 20 instances to accept the traffic, then spread is probably the way to go forward. And in order to we need to push in this metadata. This metadata rack is something I came up with. The his and her is not something Nomad knows about. So in the Nomad configuration, in the client section, we need to add the meta tags that we want to apply to a certain node. This is still a very static way. So I need to predict in advance how many instances I want to run, and that's not something why we move to the cloud. That's not why we set up Nomad. So we want Nomad to be able to make decisions on our behalf. So it might be in the middle of the night when America comes online. You're slashdot in the middle of the night. And that's not something you want a human to wake up for, to basically scale out your infrastructure. So the Nomad team came up with a function called the Nomad Autoscaler. It was introduced in Nomad 0.11, and it's currently an independent project. So it has an independent release cycle, so that they, because they're still developing the tool, they're still developing, listening to the industry and the community about what use cases to provide for. So that's why it's on an independent release cycle. And it is gaining new functionality every release. It's built for both horizontal and vertical scaling, so I can scale the amount of instances I have, but it also now is able to scale how many clients I have. So based on how much leeway your Amazon account is, you can basically scale infinitely until Amazon runs out of hardware or your credit card runs out of money. And same as Nomad, it's extendable by your own or community plugins, which then now are becoming available, several of those. If HashiCorp doesn't see the use case or is not comfortable maintaining code for cloud service they're not particularly familiar with. So how does the Nomad Autoscaler work? It makes decision based on checks that you've written yourself, and a check is a combination of 3 things. First, you need to have data that is queried from some form of APM, think Prometheus or Datadog. Then it's based on a strategy. Basically, you tell it you need to obtain a certain value, and that's something you define in the target. Multiple checks can be combined, and then in order to make sure that you'll always have enough resources online, they defined that the check that will have the outcome of the most resources will win. So if you have two checks. One will say we need to scale out. One says we need to scale in. Scale out will win. Same for scale out versus, and like we stay the same. Or let's say we need 10 instances. The answer for one is 10 new instances, or we need to scale to 10. The other one says scale to 5, then scale to 10 will win. That way, you will always have the right amount of resources available. But people new to Autoscaler sometimes find this confusing, so I'll address it here. So it's a bit meta. The Nomad Autoscaler can run in Nomad. So here I deploy the Nomad Autoscaler into Nomad. It's the same type as before. It's a service, and we deploy it off of a Docker image that HashiCorp pushes into Docker Hub. And then we provided some configuration in a file. And the configuration basically is we pointed to our APM. Well, no, first we pointed to our Nomad instance, and by some Nomad variable magic, I basically pointed to its own IP address. Then we pointed to our Prometheus instance, which in our case is just a service we discovered using console. And we defined that the strategy we're going to use for this project is target value. So the project will need to tell us a certain value for whatever query we come up with. So Prometheus, let's investigate a bit more what that is. It's a metric system. It's pretty much the default for cloud native. It came out of SoundCloud a couple of years ago, and in contrary to the older generations of metric systems, it's actually a pool-based system versus what used to be a push-based system. So Prometheus needs to know where your metrics are, so it can scrape it. But the pretty thing is you can now define your own exporters basically with that expose you the metrics that you're interested in. So now let's integrate the autoscaler is running also in Nomad, my blog is running in Nomad, and let's add the scaling stanza. Scaling stanzas go into groups, and we can add it in with enable this false, then it's just in there, and when we need it we can flick it on, but I always start them with true. We can define a min and max, so that if we have a thundering herd, we don't actually blow up our platform, but I say there's a maximum of 20 instances of my blog can run. And then we add the policy. We basically say go into Prometheus, do a certain query. In my case is look at the metrics that traffic, our ingress controller, provides, and look at how many people are actually concurrently connected to my blog. And the target value should be 5. So if you go over 5 concurrent users, you should be scaling. Or if you drop below 5 or an increment of 5, then you should start making decisions. And we add a cooldown option of 20 seconds. So don't start flip-flopping when the traffic goes up, traffic goes down. No, just make sure that you look at 20 seconds increments, so you don't start to go crazy while increasing or decreasing. We can visualize all of this stuff in Grafana. Grafana is, for me, the gold standard with regards to observability dashboards. We can add one for all the metrics we see come in for our platform, not just our platform, but also the autoscaler emits metrics which you can scrape. So this is a sample dashboard, shows us some metrics about memory, how much CPU is used, but the block in the middle is what's interested. Here we're going to see two things. One is the amount of connections that are coming in, and on the left, and the amount of nodes we have running on the right. Not just right, it's the right hand y-axis. So if you remember correctly, or I didn't really explain, I started the project with a count of 3. And now we can see here on this graph that it actually already made a decision. 3 is too much. We can go down to 1. And if we look actually into the logging that the autoscaler emits, we can also see this. So basically, it here this is the logging, and on the third line you basically see it's we want. Well, it did the query, it came up with a number, and it says based on we currently have 3, we should probably go down to 0 because we have no traffic whatsoever. But because the user says there's a minimum of 1, we're gonna end up with just a 1, and then you see it the platform scaling, which is pretty cool. So if you do the reverse, basically we apply some pressure using a tool, in this case called Hey, or this Gatling, or whatever tooling you're comfortable with. You can actually see here now. In this case, we apply 30 concurrent connections over a minute, and we push it basically into my local host. And then we can see the number go up on the right. That's the blue line. That's the connections. And then we also already see that it starts ramping. Nomad is ramping up the amount of hosts or instances that is online. So, and then the reverse, if we, after the minute the Hey stops the connections, we actually see the platform make this decision to go back down again. So now we have a very nice way of automatically responding to the thundering herd. This to me is very interesting, but it's a bit scary. Basically, having the platform make decisions on its own, that's what we paid for, but that's something we still want to track. So Grafana, the lovely people at Grafana came up with another tool, Loki, what they say is the Prometheus for logs. It's a fairly simple way of storing logs. Historically, people put them in Splunk or in the Elk stack, but that's a platform in and of itself. So I'm showing off Loki, which is a way to store the logs. So that's something we can look at, or actually correlate between the graphs we're seeing, the metrics in the graphs we're seeing, and the log events that are happening. There's 2 ways of getting stuff into Loki. Since we're using Docker, we could use the Docker plugin that the people at Grafana provide. Then we do this using a command line Docker plugin install, and then we actually update our blog Nomad job by adding a little logging stanza and saying we want the logging pushed to whatever plugin Loki provides, and then we push it to a certain URL that is exposed by our console cluster. Currently, the Loki driver is blocking, so if your Loki platform actually goes down, you'll have trouble manipulating your container. So probably what at the moment you want to do is run a sidecar. Just like Kubernetes, Nomad can do sidecars. In this case, I'm starting the Loki command line tool called Prometheus as a sidecar to our blog task. So in our blog.nomad file, we add another task into our group, which basically says I am a sidecar that needs to start before the actual container, and we want to start Prometheus with a certain configuration. Now, the configuration for people that are used to Prometheus is fairly similar. Well, it's actually similar because the code is code reuse from Prometheus, and it would basically, what we do is we point it into a path that is available to our local tasks, and since it's a sidecar, it can actually read into the blog container space, and we basically start scraping all the log files that are Autoscaler related, and we match on any event that is tagged with task autoscaler, and then we convert the JSON it emits into things we can query for in Loki. This way we can now annotate our graph. So basically we can correlate between metrics and events. We correlate on the key value per task is autoscaler, but we filter out the scaling targets. That way you've seen the vertical blue lines already on all the graphs before, and that's now an annotation in Grafana, which you can hover over, so you can actually see the event that has caused you can see the event that happened at the same time as the metric. So now here, if we hover over it, we can actually see that there was a decision made to scale from 6 back down to 1 running instances. So if you want to try this themselves, the lovely people at HashiCorp have packaged this into a demo you can use yourself. But have we moved everything to the cloud? So now we have a cloud infrastructure with Nomad running on top. We have an autoscaler on top of that, so we can survive some form of a peak in our traffic. But still, there's a limit. There's a limit to how much instances I can run on the amount of Nomad clients I've installed so far. So capacity planning wise, I need to predict what's going to happen. Even I need to basically predict what the craziest peak is in the year. So we're still basically in a situation where we need to plan ahead to what's going to happen. For this, we now have a plugin in the Autoscaler that can manipulate, in this case, an AWS autoscaling group. So I can not only grow the amount of instances I'm running, but actually I can scale the amount of virtual hardware I'm running. In this case, I'm saying scale out my availability group within a certain allocation I'm giving you. Within the allocation I've defined when we set up the autoscaling group. So we can not only grow into our hardware, we can grow our hardware where we can then again grow into. So instead of the target that we had before, we now have the AWS ASG autoscaling group target. So what does that look like in our blog Nomad file? We change the query in our policy, but basically in this case it's quite long, convoluted, but what it boils down to is work out if my CPU load is above or below 70%, and if you go over, start expanding my cluster, which is the bit below my target. No longer is a hard number, but it basically says based on the value that we have that coming from the policy, scale in, scale out the amount of resources we have. And if we look at the logging that's emitted from that, it's fairly similar. So we have a Prometheus query that comes up with an answer, and in this case it says my average load is 95, so we need to add more nodes, and that's what we see in the bottom, and now scales from 1 to 2 nodes. Also, this you can try yourself in the repo I mentioned before. You have also the cloud demos, and then you can do exactly what this is. So now I believe we've proven that we can move to the cloud, and it can scale infinitely within AWS means or your credit card's mean. Thanks for listening. If you want to contact me, you can use email, Twitter, and this presentation, by the time the recording goes out, will be uploaded into my SlideShare if you want to revisit this talk.